The purpose of this section is to discuss why we need units and how we can convert from one unit into another unit. First of all, standards of measure are sets of units of measurement for length, weight, and other quantities. These standards of measure are defined in a way that is useful to a large number of people. Here's an example of why we need to include units with any measurement. Say your friend said, "I drove 45 today." What exactly do they mean? Do they mean they drove for 45 minutes, 45 miles, 45 miles per hour, or something else entirely? Without specifying the units, there could be a lot of confusion as to what your friend actually meant. Before we can discuss how to convert one unit into another, let's talk about the metric system. The metric system is the internationally agreed upon decimal system of measurement that was introduced by France in 1799. It is also referred to as the International System of Units, or SI units. The metric system is the official system of measurement for almost every country in the world. The United States, Liberia, and Myanmar are the only 3 countries who do not use the metric system. The metric system has a single basic unit of measure for each physical quantity. As an example, in the English system, length can be measured in inches, feet, yards, and miles. In the metric system, all length is measured in the meter, abbreviated with the letter M. Mass is measured in grams, abbreviated G. Volume is measured in liters, abbreviated with a cursive lowercase l or a capital L. And time is measured in seconds, abbreviated with an S. In order to represent a quantity much larger or smaller than our base unit, we will use a prefix to distinguish how much larger or smaller it is from the base unit. As you can see from this table from Wikipedia, there are a lot of metric prefixes. Let's look at a few examples of how we can convert units in the metric system. If we want to convert 250 meters to centimeters, we first need to identify where the decimal point is. Then we need to count how many prefixes we move in order to get from our starting unit to the ending unit. In this case, in order to go from meters, which is the base unit, into centimeters, we must move 2 places to the right. Now we have to do the same thing with our decimal point. When we move the decimal point 2 places to the right and fill in any missing zeros, we end up with 25,000 centimeters is equal to 250 meters. Let's look at another example. Now we want to convert 250 meters into kilometers. Again, we find where our decimal point is first, then count how many places we need to move in order to go from the base unit to the prefix of kilo. Each tick mark in this picture represents a prefix. I have omitted some of the names since they are prefixes we won't really use in this class. In order to go from the base unit of kilo, we move 1, 2, 3 places to the left. We have to move the decimal point the same way. When we do that, we end up with 0.25 kilometers is equal to 250 meters. Let's look at one last example in the metric system. In the previous examples, we always started at the base unit and converted into a different prefix. This time, we won't start with our base unit. We want to convert 500 milligrams into kilograms. First, find the decimal point. It might also be a good idea to add in a few zeros before the 5 to make moving the decimal point easier. Remember, leading zeros before our whole number or trailing zeros after the last number in the decimal do not change our original number at all. Starting at milli, we have to move 1, 2, 3, 4, 5, 6 places to the left. Now we have to move the decimal point the same way, 6 places to the left. When we do that, we see that 500 milligrams is equal to 0.0005 kilograms, or 5/10,000ths of a kilogram.